Hello everyone, welcome to my channel Indian School of Physics. Guys, this is Nitin here, and here I have come with the Fizika problem number 16. It is challenging ring. It's quite tough problem in my opinion. Guys, this video is brought to you by Indian School of Physics and Unacademy together. And my current courses on Unacademy are course of Iron Picture Foundation and for JEE Advanced 2023. Currently we are doing Center of Mass in this topic and Emerge for JEE 2023. In this batch we are doing Laws of Motion currently. And advanced courses for JEE 2022 in Hindi is already going on with the Fluid Mech and EMI and AC. And there is a Spark batch in English for JEE 2023. We are doing kinematics in this. Guys, you can access my theory courses of last year, which are of advanced plus levels for boosting your JEE preparation. You can unlock these courses on Unacademy using my code Nitin sir, and for more info you can visit www.unacademy.com. and guys, trust me, physics will never be the same again. So here is the problem statement. A uniformly charged ring of radius r0 and total charge on the ring is q0. There is a point P by a very small distance of x. X is very small compared to r0 from the center C in the plane of the ring as shown. The magnitude of electric field at point P due to stationary ring is E0. Now the ring is rotated with the constant angular velocity of omega naught about an axis passing through its center and perpendicular to the plane of the ring. The magnitude of magnetic field at point P due to the rotating ring is B0. Then the ratio of E0 by B0 at point P, if it is of this form, alpha x c square divided by omega beta r square plus gamma x square. Then we have to figure out the value of alpha plus beta plus gamma. So in the Fizika paper, I think there was slight misprint here. This went as cross. Actually, it is alpha x c square by omega times beta r square plus gamma x square. So let's discuss this problem here. And yes, there is no integration required in this problem. So we are going to use the logic of Gauss Theorem and Ampere's law in this. So calculation of electric field. So in the plane of the ring, you can see this point X is very close to this center C. So what we are going to do is we are making a Gaussian surface here, which is at a distance of, you can see here in this diagram, we know the value of electric field on the axis here. So you can see field on the axis due to this ring is kqt by r square plus t square to the power 3 by 2. It is on the axis. Alright, and we have to find out this EP, because I am taking this cylinder very small, since r0 is very large compared to this t. Here actually the orientation of this Gaussian surface will be in this form, vertical. So let's say this flux is phi 1 and this flux is phi 1 by symmetry we can say, and through curved surface it is phi c. So I can say here, since there is no charge, 2 phi 1 plus phi c, this is going to be 0. Alright, here. So now you can see the phi 1 value, it is E times pi x square. The reason being, I'm saying here this E can be assumed to be very almost constant you can take on these surfaces, and this t is very small. So this radius is x, so pi x square, and here EP into 2 pi r L logic we are applying. So 2 pi x into 2t, and that sum should be 0. So here EP value can be calculated, and then if we approximate this as under the assumption r is very large compared to t, so this result is going to be giving us kq q0 x by 2r cube. Again, the direction of this electric field will be towards the center of the ring. So this I have done earlier in one of the problem uploaded on this channel. So I think some of the students probably would have this idea that this this method we have already discussed in this channel. Now the second part, calculating the value of magnetic field at this point for the rotating ring. So this is quite tough in my opinion. So for simplicity, I'm just going to write so that I have to write less number of terms. I'm defining this current I. I'm treating this rotating ring as a current carrying ring with the current value as q omega by 2 pi. So now here we know the value of magnetic field on the axis By, and that is mu naught I r square divided by 2 times r square plus y square to the power 3 by 2. This is a standard formula everyone should know, and near the axis we can say x is very small compared to this r, because this point is very close to the center of this ring. Now this is how these field lines are existing here. We are interested in finding field lines at this point P. Alright, so at any general point here, this magnetic field will have two components, and since it is very close to the axis, I'm taking this point to be very close to the axis. So this By and this Br, two components are there. I can take a Gaussian surface here in order to find this Br. If you remember, I have used this logic in one of the previous videos also, where a concept of mechanics and magnetism was taken here. It was a rolling ring, so it's a link you can see in the description, in the I button here. All right, so you can see here, if I take this, and this method is quite useful in finding out this radial component of magnetic field. So I'll be using this Gauss theorem here. You can say net flux through this is going to be 0. So flux through the top part by plus dy and into pi x square, and here it is going to be by into pi x square, and through this curved part it is going to be br into 2 pi x dy. So by using this, you can see here a very nice result is going to come. Br will become minus x by 2. Here I am going to take this minus x by 2, and this will become b at y plus dy minus by divided by dy. So this becomes db by dy. So this radial component of field is minus x by 2 db by dy. Now we know the value of b on the axis, near the axis. So if I differentiate this, finally I am going to get this result for Br. I'm not showing the differentiation part. I think you can easily do that. So I'm getting this B as 3 by 4 mu naught I r square xy divided by r square plus y square to the power 5 by 2. Now by using this Br, I am going to calculate the value of magnetic field at point P. The next I am going to take Ampere's law. If you remember, even this method I have done in one of the separate problem, that was magic of magnetic field lines. Its link also you can see in this I button here, and we all know that at the center the value of magnetic field is mu naught I by 2r. So I'm going to take a very small loop, and circulation of B I'm taking in this direction. So the field, since this height is very less, this h is very less here, you can say this value of B dot dl in this part, and since there is no active current element passing through this Amperian loop, so B dot dl is going to be 0 in this loop, right? So in this part you can see B naught into h it will become, and here this will become Br, and Br we have already calculated here. Br is coming as a function of x, so Br dx we can calculate from A to B, and at this point I can assume that just at this point and above, this value of magnetic field is Bp. There will be another component also, but we are taking the approximation that nearby this B and AB point is very close to OP. It is almost at this level, so I can say nearly this field is Bp. So Bp into H we can write with the negative sign, and on this line, on this, in the plane of the ring, the radial magnetic field is going to be 0, so Br is 0. So on this loop, when I apply B dot dl, you can see here I have just explained this part plus B naught H, and this will be minus Bp into H, and this is going to be 0. So if somehow I can calculate this, I can find out this Bp value which we have to find out. So let's calculate this integral Br dx from A to B. So Br dot dl for AB part, 0 to x we will go, and this will be the Br, into dx. When you simplify this, this will become x square by 2, and we are going to get this expression here. All right, now we can use the approximation. R is very very large compared to h, so we are going to get such a simple relation here. And when I substitute these values in this equation, you can see I'm going to get plus b naught h minus bp into h plus of this. When I simplify this, I'm getting bp is equal to b naught plus 3 mu naught I x square by 8 r cube. And b naught value is known to us, very close to the center. It is mu naught I by 2r, and this value we have already calculated just now. So the value of magnetic field at point P comes out to be mu naught I by 2r 1 plus 3x square by 4r square. This is going to be the answer for this magnetic field at point P. Now we can relate this. By the way, here I would like to mention, as there were some queries raised from people who wrote this exam, that the BP has been approximated to higher order, whereas this EP has been approximated to first order. So idea was, because in the problem itself the expression is given in this manner. In the problem the value of ratio is given in this form, right? So we have to get the idea that E we have to write something proportional to x, and B we have to involve r square plus x square. So that was I think a good hint that electric field you have to approximate to first order, and magnetic field you have to approximate to third order. Anyways, here, so once we substitute the value of I, that is q omega by 2 pi, so this EP by BP value we can simplify, and we will use this 1 by mu naught epsilon naught is equal to c square result. So EP by BP comes out to be 2x c square divided by omega times 4r square plus 3x square. And then we can pick up these alpha, beta, gamma, and 2, 4, 3. So alpha plus beta plus gamma is going to be 9. This was the final answer for this problem. So I hope guys you have enjoyed, and there is a lot of learning. See, individually these two parts I have already done on the channel, using Gauss law to find BR and using Ampere's law. In such situation, in magic of field lines, you can see those problems also. Their links are given in the description, also in the I'll post in the comment section. And guys, another announcement is, so in Unacademy the subscription prices are on discounted rates for 1 week. So these prices are they will be 10% off, and if you're using the teacher's code, which is in my case it is Nitin sir, you'll be getting additional 10% off. So I think from 13th September to 20th September this will last. So those who want to take admission into one of the program or take subscription, they can opt for it. This is it in this video. I hope you have enjoyed this. It was quite a challenging problem, and yes, slightly here some misprint has happened in this, but I think it was probably understandable. But anyways, there is a lot of learning in this problem. So if you have learned something new, please leave a like, share this video with others, and if you haven't subscribed my channel, please subscribe it. I'll be coming up very soon with another amazing problem. Thank you. Thanks for watching it.